Hey guys, okay, we're going to do a video on 1-21, triangle mid-segment theorem, or as I like to call it, the evil eggplant theorem, inspired by one of my favorite cartoons when I was a kid. All right, so let's talk about this for a second. So I drew up this triangle here, all right, and we're going to take some measurements. So if I measure here, okay, the length of this side here is 14 centimeters. And, right, 7 is the middle. That dot right there is right on the middle. So I'm going to mark this off as the midpoint. So that side and that side are congruent. Okay, I'm going to do that again over here. And that is the same, basically the same deal. Okay, so this and this are congruent. Okay, so now watch what happens. This is actually an equilateral triangle, or it should be something of. All right, this here is about 14 centimeters. All right, so I have 14 centimeters here. Then when I measure this one, I get about 7. Okay, I just want you to see that that's physically happening, right? When we talk about the mid-segment of a triangle and how this is half of that. Or, as far as the evil eggplants are concerned, it takes 2 of the smaller evil eggplants to equal 1 large evil eggplant. Okay? All right. So next, let's take a look at a couple examples. All right, so this example here. All right, let me make sure you guys can see that. Yep, okay. So this here, if this is 8, and all these congruency marks are here telling me what's going on, right? Telling me that D is the middle of A and C, E is the middle of B and C, and F is the middle of A and B. I have all mid-segments. Well, how this works is this here line or side is parallel with this side. So if this is 8, this is 16. This is parallel with this side here. So if this is 6, this is 12. If this is parallel with this side, then this is 7 and this is 14. All right, and then from there, all I need to do is add them up, which I will do with my trusty calculator. 12 plus 14 plus 16, and I will get 42. Okay, and that's how we answer that question. Next. Okay, this got smudged a little bit. So I have this here that's 20. Right? Now, right, what I forgot to put in is the congruency marks. Once I have the congruency marks, right, which are on the original problem, once I have the congruency marks, I know that this is a mid-segment. Or some students like to look at it as this line is bisecting these sides, and that's fine too. Right? But you just need to understand that S is the middle and R is the middle. And this line here is in the middle of this triangle. Okay? So now that means that this, right, is half the size of this. So I'm going to multiply this by 2. And set it equal to this. Okay? Then I'm going to solve. So I'm going to distribute, and I'm going to get 4x plus 56 equals x plus 20. Okay? I will, let's see, I'm going to subtract 56 and subtract x. Those cross out. All right, so I get 3x equals negative 36. Then I divide by 3. And x equals negative 12. Okay, that's how we do that. Next, and lastly. Okay, so this is your typical problem that you'll see with mid-segment theorem, as you see a lot of extra information. What you need to look out for is these congruency marks here. Once you realize you have those congruency marks, and then this is the middle of that, you have an evil eggplant question. All right, so we're going to use the evil eggplant theorem, right? The evil eggplant theorem doesn't require any of this, so we're not going to use that, right? We're just going to use the mid-segment and the end over here, and I'm just going to multiply it by 2. So I say 2 16 plus x equals x plus 32. Distribute, so I get 32 plus 2x equals x plus 32. This is going to come, whoa, I almost made a mistake there, see? That's kind of why we need to slow down and check, right? I caught that I was going to have 0, and I knew that wasn't going to work out. I could have 0 for x here, actually, but it just didn't seem right to me, so I double checked. Now, I'm going to subtract x here, get x. I'm going to subtract 32, and that will cross out, and I'm going to get negative 9. Right, and that's it. Let me just double check that with my calculator. 23 minus negative, or whoops, 32, negative 9. There we go. This is a good time for me to say, keep in mind, x can be negative, but the sides can't be negative. So if I get a negative, I just need to plug it in and make sure that everything's going to be positive. Okay, in fact, if you look here, if I plug in negative 9 into there, which is not part of the question, but I'm just going to point it out. This would be 9 plus 1, which gives me 10. So it still works. Okay? All right, guys. I hope you guys found this video helpful.